So that's kind of data entry. Another thing that comes more into data editing is this idea of what the shape of the line actually is. In ArcGIS, the default is that lines are stored as a series of straight line segments. But we can do other things such as a spline fit, which fits a spline curve, which is a polynomial curve, to all of these points here, 1 through 11 that we see here. And in this case, we're actually using two different second polynomial equations to fit first the, or two different polynomial equations, one first to fit the top part and a second one to fit the bottom part here. And in this way, we can smooth the line. We're taking into account where the vertices are by where the black dots are here. And we're also taking into account that this thing, whatever it is, a river or some other kind of smoothly varying linear feature, is not really made up of these straight line segments that we see with the lighter gray line, the lighter gray thicker line, but it's actually better represented by this spline line, this polynomial line, which is shown by the thinner black line, which is labeled as the smooth line right here. So sometimes we have a line that has too many vertices along it. And too many vertices means extra data storage, and it might mean that we could just get rid of some of those. We could weed out some of those vertices because we don't really need them all, because it's just providing us more detail than we need. In this example here, what's being shown is, first of all, a line with each made up of line segments, where the line segments are connecting the vertices. The gray area that we're seeing here is similar to a snapping tolerance, but it's a weed tolerance. So it's going to determine whether or not we should weed out individual points. The first thing we have to do is determine how many points we want to at most weed between. And in this case, it's between 4 points, 1, 2, 3, and 4 in this case here. What we can see is that if we put in that weed tolerance between those 2 points there, if we think about if the straight line was running here, the weed tolerance would be the width of the gray bar that's being shown here. We can see that the 2 points between fall outside of the weed tolerance. But then what we do then is we shorten this weed tolerance down to this, and then we say, okay, in this case here, we have a point that we don't really need because it's within this tolerance of, as long as it's somewhere within this gray area, we're happy enough with it. So we can redraw that line without that vertice there at all. So that vertice has been taken out. It's now shown as a circle without any black fill. And now we're just going to represent the direction from here to there by one straight line. Then we do the same thing again, starting with where we began. We do 4 more vertices. We see that these 2 points are outside the tolerance, so we don't remove any points. When we go down from 4 to 3, we see once again this point is outside of the tolerance. Once again, we don't remove any, and then we just do it again. None removed here. When we go down to 3, this one is within it, so once again, we would drop out this vertice and just kind of smooth that line a little. So if you can compare what we started with to what we end up here, not a lot of difference, but it did remove 2 vertices and resulted in a slightly more smooth line where the major details are not removed. And all of these things we can set up while we're digitizing. So if we're creating new features in ArcGIS Pro, we can do all these sorts of things like set these different tolerances and our snapping and all those sorts of things. Here's the snapping down here, and set it up so that as we're digitizing, all of these things are being taken care of so that we can get the best result possible. Another concern that sometimes comes up as we digitize, especially polygons, is this idea that oftentimes we have 2 polygons that share a boundary. If that boundary is only digitized once, think of like a boundary between 2 states. If it's only digitized once, and that same line is used to make 2 different polygons, we're in good shape. But if 2 different people did the digitizing, and they were trying their hardest to follow the state boundary, but sometimes they just digitized in slightly different areas, we can get 2 different things that result. One is going to be a gap where in this gap, this little area here is not assigned to the state to the left or the state to the right. It's assigned to neither state. And then we get these little areas of overlap. And these areas of overlap would be ones where one state overlaps the other state, and of course that does not happen. These little issues here are sometimes called sliver polygons, and we bring it up just because it occurs a lot. If the digitizing was not properly done, it's very common to get sliver polygons just because we can't digitize the edge of one polygon very easily right on top of the other polygon if we are digitizing these things by hand. If we're using on-screen digitizing or using a digitizing board and a puck to digitize, it's not easy to click on exactly the same boundary that someone else clicked on, especially if you have a lot of curves and irregularities in the lines. So this is something that we just have to be very careful about, and if these sliver polygons do come up, then we have to address them. Some different ways to address them would be to eliminate one of the states and use the boundary of other states as and when you're redigitizing the boundary of the state that you removed, or sometimes it's possible just to remove the smallest sliver polygons, identify the polygons of the smallest area, and delete the sliver polygons, although that might lead to more unexpected results.